Okay, last time we looked at investigation 1, which is graphing the quadratics in intercept form. Now we're going to do investigation 2, which is graphing quadratics in vertex form. Now, just to use the same technique with the graphics calculator, I've already entered the quadratics, which are listed there in the investigation 2. I've put them into the y equals in the graphics calculator. Now I've just highlighted the first two, and we'll see what that looks like on the graph. Notice the commonality between these two is that we have x takes 3, plus 2, plus 2. The a value out the front is the only thing that is different. So when we graph this, we see it actually has a vertex at 3, 2. Both of them have a vertex at 3, 2. If I press the trace key and I head on down to that vertex, we'll see that they are the coordinates of the vertex or the turning point. So down to here, it's approximately 3, 2. We could also have it upside down if we used a minus out the front. So if I plotted minus 1 followed by x takes 3 squared plus 2, then we'd also get a vertex of 3, 2, except this time it comes from the bottom because there's a minus out the front. Okay, so in general we can say that the vertex formula is y equals a x take h squared plus k, where this is the vertex, h comma k is called the vertex, and it has to be minus h and it has to be plus k for that vertex to work. Once again, the a out the front is exactly the same as the previous case, which was that determines the shape, and if a is positive, then we have the graph going up. If a is negative, we have the graph going down. And the larger the a, that implies the steeper or the narrower the quadratic graph. Okay, so now the reason why this would occur is we can, rather than learn this off by heart, we could actually see that this is really just a transformation, because if you look at the graph of y equals x squared, it will go through 0, 0. That's y equals x squared. I've actually did that in class here. That was the fourth graph I did. And so I'll highlight that one and press graph, and you can see y equals x squared goes through 0, 0. Now what we're going to do is transform this into this one over here. Now remember, when we're doing sine curves back in pure maths A, we said that if you've got an x take h, you move it to the right by h. So that means this whole graph has to be moved to the right h units, and plus k, that plus k is being added onto the y, so everything's got to go up by k. So the vertex goes across h and up k, and that's why the vertex form is y equals x take h, because it's being moved across h, all squared, because originally we were x squared, and then we've got to move it up by k, so we go plus k. And in general, you can have an ax squared, that'll be just slightly a slightly steeper or less steep graph, so we can in general just put an a out the front. So we could have started off with ax squared, and that's transformed into ax take h squared plus k. Okay, so all these here have got 3, 2, 3, 2, 3, 2. They all have a vertex of 3, 2. The number out the front, the a value, is the only thing that just changes the shape of the graph. but they all have a turning point. So if you look in question 3, it says if a quadratic is in the form a x take h squared plus k, then its vertex has coordinates h comma k. Okay, now that we've seen the graphing, we can now start looking in more detail at the algebra involved in these quadratics. So we'll start off with 1a1. We need to find 5 things: x-intercepts, axis of symmetry, vertex, y-intercept, and graph it and check on the calculator with these functions here. I'll do the first one and you can do the rest. Okay, so the first one is y equals x plus 2 times x minus 2, and part 1 we have to find the x-intercepts. Now the x-intercepts is when it makes y equals 0. So the x-intercepts you can easily read off from the intercept form that it's going to be plus or minus 2, because if you put 2 here where x is, minus 2 there, you'll get 0, and if you put positive 2 there, you'll get 0. So they are the two x values that will give a y value of 0. So that's where it cuts the axis. 2, the equation of the axis of symmetry. Now the axis of symmetry is halfway in between the intercepts. So axis of symmetry is the x equals 0 line, which is the y-axis, because that's halfway in between plus and minus 2. Part 3, find the coordinates of the vertex. Now the vertex, we first of all find the x-coordinate of the vertex. The x-coordinate will be the same as the axis of symmetry, because that's where the vertex lies. It lies on the axis of symmetry. So the x-coordinate is 0, and if we want to find the y-coordinate of any x value, we need to substitute it back into the equation. So we substitute 0 into here, so we have y equals 0 plus 2, 0 take 2, so that's 2 times minus 2, which is minus 4. So therefore we can say that the vertex is 0 comma minus 4. Part 4, we need to find the y-intercept. Find the y-intercept. The y-intercept occurs when x equals 0. So we're going to put 0 into the top, and we've already done that in part 3 coincidentally. So we'll just do it again. Y equals 0 plus 2, 0 take 2. Sometimes it's different, the vertex and the y-intercept, but in this case it turns out to be the same, minus 4. Now part 5, we have to sketch all of this, put all this information together on a graph. So we can put in our x and y axes, and we have to label all these critical points. So it cuts at minus 2 there and plus 2, which is there. They are the two x-intercepts. The axis of symmetry is in between the x equals 0. That's the x equals 0 axis of symmetry. And the y-intercept is the vertex, which is 0 minus 4. So we've got to come down 1, 2, 3 around about here. So vertex 0 comma minus 4. It cuts at minus 2 and plus 2. So the graph comes down, turns at the vertex and back up. And here's our axis of symmetry, x equals 0. Now you could check that on the calculator by putting that function, typing that whole function into y equals. And if you did that, you would get this graph that we produce manually here. Okay, so you try now the remaining ones there. I'd try B, C, D, because B is like a repeat of that one. C is a little bit harder in that the axis symmetry is halfway between 1 and 2, which is 1.5. This one's a little bit different, this one and this one, D and E, because you don't have two brackets, but you can consider that X as X take 0. So that's another one to try, which is different. So at least B, C, D. Okay, pause the video and come back for the solutions. And here are the solutions to 1A1. We've got 1A, B, C, D, E, and F sitting over there.